Hi there, this is session 35 of programming from the very basics using Python. In the last session, I talked about how to read files. I told you how to read a text file, basically. I explained the usage of with clause and also explained how you can read small files completely into memory. We also call this slurping a file as a string or as a list if you're dealing with text files. Also explained the pattern that's commonly followed if you want to work with large files. If you're dealing with large text files, how you traverse line by line and maybe process them, maybe search for any substring or pattern that matters and extract accordingly. So in this session, I will talk about how to write to files. I'll tell you how to write to a text file and the common idioms that you normally follow when you're dealing with text files, both for reading and writing. So let's get started. In this particular session, what I'll do is I will tell you how to first create a file and write to it. And in order to create a file and write to it, this time you use open. Okay, sorry, I need to select the kernel again. Sorry for this. Yeah. In order to open a file, you use open function, as I told you. This would return a text IO wrapper, or it might return a buffered reader or buffered writer based on the modes that you use. But we in the previous session, I told you that you open a file just by passing one parameter, which is the path to the file, right? So I use something like readme.md like this, for example, and to open up a readme file that's in my current directory. But if you pass just one argument, it is assuming that the file will be open for reading and it'll open in text mode. But if you want to change that, you can pass the second parameter, which is the mode in which you want to operate on. So the default mode is read, but if you want to change it to write mode, you can actually use write like this. Either you can use just a letter called W, a small w, to indicate open for write mode. If you want to make it more clear and more elaborate, I would recommend using the keyword argument like this, so you know that's open for write mode. So I'm going to use a keyword argument so it makes it more readable. That keyword argument is not compulsory. Second parameter is you can pass it by position or as keyword argument here. So when I say mode is equal to W, that's open for write mode, and I'll say as out file, for example. Here's something that you should know. If there is a file called readme.md already available in the current directory at this moment, that file will be truncated the moment you open it. The entire file contents are going to be lost. I'm going to show you that. I'll not open readme.md for now. I'll just get another file. Let's say testfile.txt. So the rule for what it does is when you use the mode as W, that's opening for write mode, if the file exists, the file will be truncated and will be overwritten henceforth. But if the file does not exist, it will attempt to create a new file. All this assuming that you have permissions to the file that might already exist to write to it, or you have permission to a directory or a folder where you can create a new file. So both permissions are required. If you try opening a file in write mode in some arbitrary paths where you might not have permissions, then you will get an exception. So I'll just show you in this case. This time I'm just going to open the file. I'm going to do nothing in here. I'm just going to exit out like this. When you exit this particular with clause, the file is open for writing and the file is closed. This will end up creating an empty file, a file with 0 bytes on almost all the standard operating systems. We can verify that. I will use a terminal here, where I'm pointing to the current directory, I hope. Yep. If I just do ls, there are many files in here, all of these program samples, but in this, you'll find a file called testfile.txt that you can see right here. If I try an ls-l testfile.txt on my Linux system, this will work also on a Mac terminal. If you're using Windows, you can use dar. That's a command that you use on Windows, right? So when you do a ls-l testfile.txt, you can see that the size of this file is 0 bytes. Now let me just create this file again and try to write to it. Before that, I will tell you what happens if you try to open a file where you don't have permissions to create. So if I try to do this, if I just say open off, I'm attempting to create a file maybe in some arbitrary folder where this user, as I've logged in as, does not have write permissions. Let's try maybe user local testfile.txt and try to open it mode as write mode as out file. I do a pass. I'm not doing anything. I'm just trying to create a file. Okay. Try running this and you'll get this error. You can see this. If you get an error like permission error, that means you lack the permissions to create file in a given directory, or maybe the file already exists and you don't have permissions to overwrite that file. If you open for reading, you may not have permissions to read that file too. There are certain files which are quite secure, even for reading. So in this case, you can see this permission error, permission denied in this particular path, because this user cannot create anything in arbitrary paths. I have to create only in my home folder. I guess that's the same restriction you'll have also on Windows these days. If you try creating in your C drive, I think mostly you'll not have permissions unless you might want to log in as an administrator. Maybe I just try to show you on Windows. Unfortunately, I can't show it in the VS Code. I have connected to Windows remotely from my Linux desktop to a Windows VM. So when you open up your Anaconda command prompt, that's what you get, right? So I just remotely connected and have the Anaconda prompt right here. So here I'll just launch IPython. And I'm the IPython shell here. And I'll try with open of, maybe I'll just give some path, like say C:, I'll put a / here. When you use /, it'll work on Windows machines. I've seen that in the recent versions. And I'll say testfile.txt for write mode as out file, and just give a pass here. You can see you get a permission error even on Windows platform. Exactly the same kind of a message you see here. Because as a normal user, which I've logged in as on my Windows machine, I will not have permissions to create directly in my C drive and other locations, right? So if at all you want to create files, the right place to create it would be in your home directory onwards as a normal user. If you want to access anything outside your home directory, you might want to play around with your file manager and set permissions and so on. That's a different thing, right? You need to manage your permissions for the folder. So if at all I try to create a file, however, in the current directory, let's say just testfile.txt will create in the current directory. The current directory, I guess, is that C:users CSB is what I've logged in as. So it'll create a file there. No errors. I mean, the errors and the way it works are all the same. The paths might vary, right? That's what you should know. Now coming back here, if I open a file for writing, I can write to it by two primary ways, write and write lines. There are two methods, write and write lines. So we can see that. So if I have, if I just try to manually open the file like this, I'll say open off. Let's try, or I'll use with class, no problem. It will autocomplete anyways, right? So with open off, testfile.txt, mode is equal to write as out file. And now I can use out file dot. The methods for writing, you can see there are so many methods and attributes in here. I talked about read, I talked about read line, I talked about read lines yesterday in the previous session, right? But you scroll down a bit, you can see there's a write. There's something called write through, which you don't really use. There's something called writable and readable. I'll talk about that. And you have write lines. Write and write lines are the primary ways to write to a file. Write will take a string because you open the file as a text in text mode. So you open the file for writing in text mode, right? So it'll assume if you just use W here, the file object will still be a text IO wrapper this time. If you try to print what this is, try to print it out file. You can see that it shows up as text IO wrapper. Name is equal to testfile.txt. Mode is equal to W, which indicates open for writing. If you want to programmatically check whether a file is open for writing or reading, you can actually check this. We can just say print out file dot writable and out file dot readable. Check whether you can read from it or write to it. Oh, it's a method actually. Sorry. When you see something like this, built-in method, writable, and so on. See, I'm exploring, right? So when you try to access an attribute and it shows up as a built-in method or a function object or something like that, then it expects you to call it. These won't take any arguments, so you can just call it as it is. It's a Boolean method. You can see that file is open for writing. That's why writable written true, readable written false. If I open the file for reading, file object.readable would have returned true. It's just useful for checking in what mode the file is opened, right? Programmatically, you want to check it. You can say if out file.writable then perform some write operation. Else, you can flag off an error. So if at all you have a function that opens a file on its own and calls another function that you've written, which takes in a file object, you need to ensure that the file is open in the right mode to perform read or write operation. And to do this precautionary check, you can use readable or writable method. Now let's try to store something into it. With open of test file.txt, mode is equal to w, and as out file. And if I want to store something into this file, there are three ways to do it. I'll show you. One of them is using the methods, the write and write lines. That's the two ways. And there's another way you can also write to a file, which I'll explain now. So if I can just type outfile.write and write a string here. This is a test string. Remember, write will not add a new line. I'm going to show you that. So there's a test string, and I'm going to type outfile.write of this is another string. So what I did here, to the write method, I pass a string. I open the file for write mode. You can see open of test file.txt, mode is equal to write mode as out file. And the out file is a variable that represents that file object that's opened. We call it as text IO wrapper. Now, when you say outfile.write in this block, and whatever you pass here, it's a single string that is there. Again, it's outfile.write, another string. When I exit this, it'll close the file automatically, because you know that when you exit the with clause, the file is automatically closed. To check a file is closed or not, you can use f.close, outfile.closed. It will return true if the file is closed, false otherwise. So when you run this, I'm going to check this particular file in here. I'm created my local machine, not on my Windows VM. We do a cat. Cat is a command that you'll use. If you want to try it on a Windows command line, you can use that type command. Type and file name will show you the contents of the file. It's called type in Windows, coming from the MS-DOS days, right? So there's a cat test file.txt here. You can see both these strings are written on the same line. You can see that this is a test string, this is another string, comes up on the same line that you see here. No new line is added. If you want to add a new line, you must explicitly put a /n here, like this. Now this time what I'll do is, I'll just put some arbitrary letters here. I just repeated A's and repeated B's here, so it looks very legible with new line. And I'll run this cell now. What happens to the previous data in the file? That is lost. The moment you open the file for write mode, if the file had any contents, everything is lost. You're warned, because this is a very common mistake that beginner programmers would do, even beginner users, I would say. You might have a file with some important information, maybe configuration or something like that. You just want to make some changes to it. If you open the file in a mode called write mode, all the existing data is lost. So it starts off from scratch. And the file, it doesn't matter how big the file is. And you might have a 10 gigabyte file. Your file could be 10 GB. The act of opening a file will not go and scrub the data on the disk. It just reinitializes the file as a 0 byte file, and the old data is now lost in a fraction of a second. Remember, creating the 10 gigabyte data on disk might take time, but try opening the file in write mode. In a fraction of a second, that file is truncated. You lose data. Is it really lost from disk, you might ask me? Not really. Most operating systems, they manage files differently. So if you look at most of the modern OSs with general purpose file system that you use, you need to take it to your data forensics expert, perhaps, do some file system debugging and extract the data, right? That's what I tell you. So it's not going to like completely shred the data. The data is like moved across and the file is reinitialized. The data is just there on the disk. Eventually the data, the blocks that store the data, the contents on the disk that store the data will be recycled to store new data. That's what will happen, right? When you start creating new files. So that's up to file systems. That's about how operating systems manage files. But from a programming standpoint, you lose data the moment you open the file for write mode. So it's like opening a file afresh. So it's like opening for write mode, and the existing data is truncated and overwritten. Note that. So some of you might ask me, is there a way to open a file without losing data and I want to write to it? Yeah, there are ways to do it, though it's not generally recommended. I'll talk about that too in a while now. So when I ran this cell, I guess, run the cell. If I now do a cat test file.txt, the old data that was there in that file already, that this is a test string, this is another string, it's completely truncated and lost. It's not like it opened the file and started overwriting it, because the file is truncated. Existing data is completely scrubbed off. It's just disconnected, right? And then it's going to start storing new data. Note that. And then I told you about how to write to a file by using this method, which writes a string. You probably have a list of strings already. Maybe you have a list of lines which you want to write. Maybe I'll show you another cell here. Let's say lines is equal to, it could be a list or any iterable object. Right now I'll use a tuple over. So I'll use, this is line 1 / n. Sometimes I hit the wrong keys. I changed my keyboard recently and struggled with it. This is line 2. This is line 3. So let me make it multi-line so you can see it better. And this is line 4. Basically, it's like you have existing data that is available in a tuple or a list or any iterable object which lets you iterate over strings. You can pass that iterable to write method and it'll write it into a file. Or not to write method. You have to pass it to write lines. I forgot to mention that. See. Okay, I made a mistake. I should have copied the other set. Never mind, I'll just type it with open off test file.txt. Mode is equal to write as out file. At this time, because I have a collection of strings or an iterable of strings, and each string I want to write into that file from the iterable, then you could use outfile.write lines rather. Write lines of lines. I do that. Oh. Did I run this cell? I ran this. Yes. Yeah. I know. Maybe I wrote this is line 1 alone separately, but fine. So you can see that the entire contents are written. So basically you have lines, which is a collection of strings. Remember, it can be a tuple, it can be a list, it can be any iterable object. As long as when you iterate over it, you should get a string, nothing else. If you have any non-string data, write or write lines will fail. Just be sure of that. One mistake what people do is that, what if I do this? Instead of write lines, I do write. Will it work? Is a question. It throws an error. You can see this? Write argument must be a string, not a tuple. It's very clear about this. It expects the argument to be a string object. It doesn't work with tuples or lists or any other forms. So if you have a list of lines or a tuple of lines, or you have some iterable, when you iterate over it, it just throws a string, right? Maybe even keys of a dictionary, as long as they're strings, they can be written to a file by using outfile.writelines. You should also note that every single string must end with a new line if you want to treat each entry as a separate line. If you don't have a new line, this is line 1, this is line 2, this is line 3 will all be concatenated together and written as one long line into this file. That's what will happen, right? So this is something that you should note. So I told you about the primary ways of writing to a file is by using the write method, where you can write a string, or you can use write lines to write a collection or an iterable of strings. Very basic. Now, the next form of writing is this. Let us say this. Let's say I have A is equal to 10, 20, 30, 40. It's a list. B is equal to 100. C is equal to maybe 67.8. And so D is equal to false. And F is equal to maybe a dictionary which got name, Alice, and I can just say role developer. I want to write all these data into that file. I'll write all of these into a file. And how do I do that? Well, if you just open a file, this time I'll reopen the same file, open testfile.txt. Remember, whenever I'm using a file name here as an argument, this can be a full-blown path. It can be relative or absolute path. It'll work. It must be a string. That's the one. That's the important thing here. The type mode is equal to write as out file. Can I use write method to write it? Obviously, I told you write file. Oh, sorry, out file dot write. The write method. You cannot pass a. It will fail. You can see that. It expects argument to be a string, not a list. I want to write all these data into a file. How do I do that? One way to do this would be using the built-in print function. The print function, I've not told you about this, is that it doesn't just let you write to a standard output. You can also actually make print write to any file that is writable, any file object that is writable. The standard output is treated like a file for all practical purpose by most languages, programming languages, including Python. And that's actually represented as a stream called sys.stdout. That's where it writes, right? If you go to sys module, the sys module has an attribute called stdout. It says, in this case, it says ipykernel low stream out stream, because the Jupyter Notebook interface has monkey patched it. The existing sys.stdout is changed so that it can show up in this GUI, this graphical user interface, right? But if you go to the actual Python prompt, I'll not even use IPython, standard Python prompt, I'll show you. But just type import sys here and say sys.stdout. What do you see there? It says io.text io wrapper, but it says name is equal to an angular bracket stdout to indicate that it's not a file, it's a representation of standard output. For all practical purpose, it's like you can treat this sys.stdout as a file open in write mode. Text file open in write mode. Because you can see that, you can see an encoding here, encoding UTF-8, mode is write mode. It's as if you open the file in write mode, that's a text file. So can you write to this? Yes, you can. Just try doing it. If you say sys.stdout.write of anything, it's printed on the screen. You see that? And sys.stdout returns a value, how many bytes got returned. So how many bytes got written onto that stream. That value is what is printed at the end, which is here, 15. It wrote 15 bytes. Maybe if you want to capture it in a variable, you can just say r is equal to, you can see that. You can also see that because it did not add a new line, the Python prompt came up right there. So if you want to also add a new line, you might want to add a new line like this. So if you want to bypass print function, the built-in print function, and take control of your standard output directly and start writing to it, you can treat it like a file open for write mode. That is sys.stdout, and you can use either write or you can also use write lines. Write lines will take a iterable of strings that can be written. I don't see this today, but in the very early versions of Python, I've seen some places where people take control of sys.stdout on their own because print used to be a little complex to use and it had a little bit of slowdown when they're writing voluminous amount of data. But I don't think that's any more valid because print was a statement in Python 2 days, and now print is a proper function. So print is merely a wrapper on sys.stdout.write. It'll do some format checks based on the arguments you pass and handle that, right? So if at all I want to use print to write not to stdout, but write to a file that I opened, I can say with open off. Let me just copy this cell. This time I'll use print of. I can say print of A, B, C, D. Should I call it F, is it? Okay, let me call it E there. I missed. Okay, it doesn't matter. The variable names don't matter, but just trying to be consistent in naming. Yeah. There are 5 variables I've defined. Each variable represents objects of different types: a list, an integer, a float, a boolean, and a dictionary at this moment. I can say what all variables what all objects I want to print, but I can pass a keyword argument to print called file is equal to out file. The file is equal to is a default argument in the print function definition, and the default argument that it points to is sys.stdout. The default argument is sys.stdout. I'm overriding it, I'm changing it to make it out file. So when I write it this way, now just see what happens in this file. I come out of Python here. If I just type cat and testfile.txt. See that? Basically, I'm getting the string representation of each of these objects and I'm writing them. If you want to separate them with new lines rather than spaces, you can also do that by also adding a keyword argument end is equal to, or sorry, in this case, sep is equal to new line. Separate each of those arguments as a string with a new line. You can see this. Can you read this back? Is the question. Yes, but you can read this back only as a string. You can read this back only as a string. You cannot get back the list. You cannot get back the list directly. You need to use some interesting hacks, but I'll show you what can be done now. Let's say I want to read this data back again. Maybe I'll do it in the Python shell here. See, I just stored all these contents of a list and these variables, right? All these variable data, I stored it in a file. It's now persistent on disk. I would retrieve it back into variables in another Python environment, let's say. It's like I'm saving the state, all the variables I'm saving into a file. I would retrieve it back. There are more better ways to do it, by the way. There are more better ways to do it. Magic catchphrase, pickle. I'll talk about that a little later, much in the later sessions, but I'm telling you how it's done in the manual way, our own way, right? So I'll show you in another Python shell here. I'll use IPython this time. And this time I had to open the file for reading. So this is what I do. Before I even tell you how, let's say I have a string like this. I have a string like this. This is a string, by the way. Within a quotes, I created a proper Python syntax, literal syntax for creating a list. But can you create a real list from this? From this string? Or you might think of, can I not say list of A? It does not throw an error, but this is what you get. So let's say B is equal to list of A. It'll explore the entire list, explore the entire string. That's why we print B like this. But that's what it did. It is what happens. So basically, when you try to do a list of A, where A was a string, right? A was a string. So when I do the list of A, what did it do? What did it do? It basically took each character of the string, created them as items of a list. And this might not what you want, apparently. I want to recreate the original list, which looks like what you see like in a syntax here, but it's in a string. How do you do it? Well, Python has a built-in function to manage this, and it's called eval. The eval function takes a source line and evaluates it. Let's try this. If I say eval of A, you get back the original list. Eval takes a string of Python source code, a string of Python source code, which could be statements and expressions and all that. It'll evaluate it. The most easy to use form of eval is basically evaluating an expression, by the way. But if you have things like if condition, while loop, and for loop, you might need to use compile and exec. Those are the other two functions. So this will evaluate a string which is made up of Python expression directly in Python. In fact, your REPL uses eval. This REPL takes in string as input, takes read string as input, whatever you type, and it calls eval on it. And what eval returns, that is what is evaluated by the REPL, right? That's what you see here. So if I put a normal string like this, you get this error, right? Let's try this. If I say eval of, if I try to put this string like this also, you get the same error. You see that? So eval function primarily exists such that you can create your own REPL if you want to. What is REPL? Session 1, session 2, read, evaluate, print loop. This Python shell is a REPL, right? This Python shell itself is a Python program which uses eval internally to evaluate expressions, right? Now, if at all I want to use eval to recreate all these variables, I want to name these variables. That's an interesting one. This is where things are going to get a little complex. Sorry about this. See, I don't want to hard code the variable names. I want the first line, what you read, must be in variable A, second line in variable B, third line in variable C, fourth line in variable D, and so on. How do you create variables dynamically? Using a name of the variable as a string. See, when I say A is an identifier. You hard code it in your program. I want to decide the variable dynamically. For example, um, the variable name, I'll say var is equal to, I'll just say maybe a, or maybe test var. Now what I want to do is I want to create a variable test var from var, so that when I type test var after this expression, you should have a variable called test var that represents that expression. Now, how do you do that? Is there a way to do it? Well, there are a couple of ways to do it. One simple way I can think of is directly manipulating the namespace dictionary. This may not look like a good code. Don't do this in production. There's just a little bit of acrobatics that you can do, which gives you the power of maneuvering the dynamicity that Python has. For example, globals returns the current namespace dictionary. Now just try this. Globals returns the dictionary. If I just type globals, whatever dictionary is returned, I open square bracket and I'll say var. What is var now? That variable. Var is that variable. What is the value of var? Test var. The value of var is test var. Equals, if I just say 100. Now just see what is test var. So I determine the name of the variable dynamically using this trick. Don't do this in production unless you know what you're doing. Okay. There are certain frameworks, low-level frameworks, that might use these kind of features. It's a good to use feature though, if you know what you're doing. They're fairly advanced features. Though I'm covering basics of Python. These are all some things which go beyond the basics, right? So tricks and hacks that is easily doable in Python. So what I want to do is, the list of variables I'm interested in is A, B, C, D, E. I know there are 5 lines in that file, so I want in 5 variables, right? So what I'll do, I'll just create vars is equal to A, B, C, D, and E. These are all the variables I want. And what I'll do now is I'm just going to type with open of testfile.txt. I'm just going to open the file for reading. Open the file for reading. And then I want to iterate line by line in the file, but I want to do that alongside with this entries of vars. First line of the file must be assigned to A. Second line of the file assigned to B. Third line of the file assigned to C. I want to do that. So the way I can achieve that is I can use for v, or I can just say maybe var, comma. That's var is my own variable name to represent the name of the variable. You know, variable name to represent the name of the variable. Looks very recursively confusing. Var is a name that represents something, which is a string, which acts as a variable name that will be created. That's what I mean to say, right? Okay. Hope you got it. All right. So I'll say for var, comma line in zip of vars in file. I guess, parallelization. Zip does not have any prejudice about arguments. As long as they are iterables, it will happily work. Zip, enumerate, all these are I termed as iteration helpers, not list helpers, not tuple helpers, iteration helpers. Any iterable object can be passed to it. Zip will do parallelization. Get the next element of the first iterable, next element of the second iterable, club them into a tuple and hand over. That's what it does. And this is getting unpacked in here as var comma line. And now what I do, I'm just going to use globals of var equals eval of line. Oh, I forgot that. Globals is a function. I made a mistake. Globals is a function, and the function returns a dictionary. And to that dictionary, I want to add a key, which is the value stored in var, value represented as var, and the value for it is the evaluation of the line. Python's evaluation of the line, which will be a Python expression. A, B, C, D, E. We got it. This works for most of the built-in types. Quick hacks. So for all I want to store some built-in data like lists and tuples and dictionaries and so on into a file, just use print and write it to a file. To get them back, just eval it. But remember, they must only represent data. If at all you have a function's value which is not some string or number or boolean or list or any of the built-in data types, but let's say if it's a file object or if it's a function object and so on, they show up in angular brackets. You cannot reclaim them easily. That's a limitation, right? So this is the very primary technique of what we call as, serialization or marshalling. I would not use the term marshalling for this because when you say marshalling, you have to take care of platform intricacies. Still, I could argue and say this will work across platforms because no matter what platform you use Python, the dictionary is just represented the same way, right? Yeah. So the people will argue and say, oh, when you use marshalling, it means my source machine could be Windows running on a 30-bit platform, and my target machine could be a Linux running on a 64-bit platform, running on ARM architecture. You should be able to make sure that data is compatible. Marshalling is mostly used with network level. You can send it on a network stream for serialization. Remember, all the concepts I'm talking about file IO at this moment, reading and writing files, especially your text IO wrapper, the same concepts you can apply when you're dealing with process automation, when you use sub-process module, where you can run a program and a command line program that is, and read its output, or run a program and feed input to it. They all are text IO wrappers. When you get access to a target applications or programs, standard input and standard output string, they come through pipes, but you see them as text IO wrappers. Even when you deal with sockets for network programming, if you're going to send textual data over socket, you can simply use the makefile method, which I'll discuss when I talk about socket library, perhaps if I have time, right? Hopefully, I'll see if I can chunk that in this series of videos based on the subscribers and the views. If there are more views and more subscribers, I would add more to these sessions, right? So when I talk about sockets, there you will see you can actually use socket.makefile and you can get a text IO stream and you can treat it pretty much like a file. So you can send this dictionary for apps or a network socket, get it on another system through Python, and you can recreate the dictionary there. So you can transmit data, Python data, over sockets. If you know just these basic things, this should suffice. This should suffice for most cases, as long as you're dealing with purely built-in data types. Purely built-in data types: int, float, complex, boolean, none, all kinds of strings, bytes, and bytes could be no, bytes is not a problem. Bytes are not a string could be an issue if you're dealing with encoding, but that's a very rare scenario. As long as using Unicode is fine. You'll work with tuple, list, set, dictionaries, all of them. You can string them. Here I showed you how to write it to a file and read it back. So I can put this whole thing in a program. I will formulate everything into a program. So I can just say, create one file, a new file. And this file, what I'll do is, I'll save this file as, save window goes somewhere behind. It's a bug with VS Code on my Linux system. I think they had to fix their GUI. Yeah. They should come up in the front, but it's shown behind. It's not highlighted. A small problem with their managing GTK library, perhaps. So I'll just say maybe store Python data to file. The Python data can be anything that's got it built in. Let's say I say A is equal to 100, and then say B is equal to false, C is equal to 4.6, 4.5, let's say, and D is equal to none, E is equal to, maybe I have a tuple, and F is equal to a list of numbers. This list can be nested too. You can have a list of heterogeneous data. You can have a tuple inside it. And I could have maybe another list inside it. Anything at all. And G is equal to dictionary. And the dictionary could also be quite nested. I can just say maybe host. I can say hosts rather. So I'm trying to make this a multi-line dictionary. So I've got a comma there, right? I need to end with a comma here. Every key value pair must end with a comma. That's why it's highlighted here. And then I can just type users. Anything, any kind of built-in types. I'll just create a couple of variables from A to G. Couple of variables. And what I'll do is with open of data.dat. Okay. For write mode as out file. That I can use for I don't need because open for write mode, I need write to it. So I need to iterate over this list of variables. So I need to create a list of variables. For I can just say maybe we in A, B, C, D, E, F, G, because they're all independent variables. I'm storing them all in here. And how do I do that? I can just type outfile dot write of. No, I can't use write here. How do I write all these data out? Print function. So print. Oh, I can use print directly here, right? Why am I using for loop here? Because anyway, just about few variables. I can just directly say print of this. I'll separate them by new lines. And file is equal to output. That's it. So write it all into this file. Save this. I'm going to create another file, which I'll call as retrieve Python data from file. Okay. So certain things are hard coded, like I'm hard coding the file name in here and the mode and all that, right? So you can take it from argparse module. You can pass it as command line argument, like I showed you in the examples in the last session. You can follow that. That should work just fine. And I'm going to save this file as retrieve, or I can say read Python data from file. And this will do the opposite. What this is going to do is, I don't know the data. I don't know the data. How to get it from file. Only thing I know is a file name. So I'm just going to open that file. Open data.dat for read mode as in file. In file. One, you can iterate line by line, or you can read the entire contents of list and then iterate. Any form will do. But what I'll do here, the names of the variables I want, that I pre-decide. I just call this var names. The same thing what I typed in the REPL is what I'm putting it here. And then I'm going to iterate line by line from a file. So I'm going to use a for loop, but also along with variable names. So I'll just use var comma line in zip of var names and in file. This time I can just use globals of var equals eval of line. If you come from backgrounds like TCL, the moment you see eval, you'll say, Python has eval. So amazing. TCL is known for it, where you can always take a string, eval a string, and it becomes a script, right? But use this with caution because use it for very simple use cases. Don't do things what TCL programmers did. When the code goes to scale, it totally becomes unmaintainable. I've been there. I've been there. And I've known people who have really struggled with complex TCL scripts, right? So TCL is a fantastic language. It's a functional programming language, though. Yeah, it is a functional. You can say it's a command-oriented language. Everything is a command. That command is like a function. Okay, everything is a command there. So that's why it's called stool command language. It's a nice, simple language to learn. The syntax grammar is very minimalistic. Everything's implemented as commands, and these commands can be sort of called as procedures or functions. I can call it that way, right? They work like functions in other languages. So every single keyword, there are no keywords. Everything is a command, right? It's a well-designed language, but unfortunately, it is so simplistic that doing anything productive on it, complex code, yeah, really complex code was written in TCL in the late 90s and early 2000 era. Really complex stuff. I heard that the AOL's web server, AOL server is fully built on TCL for a long time. I think they're trying to migrate it in the future. I didn't know that. I don't know that, but I know they're largely done in TCL. And I know a couple of people working at AOL, and I used to train them at the time, sharing their thoughts on how complex that code base was. Interesting. Anyways, during the days when AOL was popular. Anyways, so here, this is something, it's a cue from that, right? This is inspired from, language like TCL. So globals of var is equal to eval of line, and that's it. I think this should work. Oh yeah, I need to print all the variables, shouldn't I? So I'm just going to print A, B, C, D, E, F, G, all the variables, and separate them by 2 new lines. Maybe each one with a new, or maybe one single new line will also do. Fine. The ID is now super confused. I'm trying to access variables here. The ID is wondering, oh, these variables are not defined. Where are you getting it from? He doesn't know the tricks that I've used here. It's a string. The strings become the variable with this little hack that is there here, right? So the IDs can get really confused when you run code like this, but I guess it's going to work. Let me try running it now. First, I'll run this program called Python store data. What do I call it? Oh, store Python data to file.py. Yeah. We have test file.dat. It's called test file.dat, not data.dat. All these are the values of Python variables which are stored in string format into the file. I want to read them back. Python read Python data from file.py. You got it back as real Python objects. In fact, if you want to test it, you can also, for every single variable, we can print the type of it if you want to. Maybe I can do it in a single print function, but it looks a little more, it'll get more complicated. Let's not do that. So I'll just type maybe for v in A, B, C, D, E, F, G. I'll just use print v type of v. This time it's going to print each value along with its type at the end. Int, bool, float, none type, tuple, list, dictionary. So you can see that working with files in Python is actually very simple. The number of lines of code that's involved to read from a file, to write to a file, very few, right? You just need to know how to open a file, make sure you use a with clause, and then to read, use read, or you can iterate over it if you want to read line by line. That's the best thing to do if you're reading large data. That's what I did here. I iterated line by line here. Or you can use read lines if you want to read it all into a list. If you open the file for write mode, you can use write to write to a string, or write lines to write a list of strings. That's like raw format. If at all you want to write string representation of objects into a file, you can use a print function. And print is very flexible to use. So many times when you want to print like formatted string with some Python data into a file, it's preferable to use a print function rather than using write method in outfile. Use write method when you want to write raw strings as is. But if at all you want to print some values of Python objects has string representation and all, right? Along with some messages and all that. It's easy to use print. So all you need to do is print whatever arguments you want to print, comma, file is equal to the file that's writable. The file is open and is writable. That's what we need to pass. The last thing I want to talk about is I told you how to write to a file, but I told you when you open a file in write mode, the existing data is gone. It's lost. What if you want to add to it? What if you want to append it? The way you do that is by opening the file in append mode. Now this time, I think there's already a file called testfile.txt where I stored some data. You can see this. Yeah, this data. To this, I want to add some more data. Maybe some strings, perhaps, right? So to do that, you can open the file. This, if you see a highlight that comes up here, that's a breakpoint. I'm not sure if it really works in Jupyter, but it works in your .py files, right? When you run it through VS Code. I will talk about that much later. Okay. We just type testfile.txt. Mode is equal to write. If you use mode is equal to write, the existing data is truncated. You don't want to truncate any data from your existing file, but I want to write to it, but in such a way that it has to go after the end. I want to append to it. If at all you want to append to a file, just use the switch A here. R for read, W for write, A for append. These are the three primary modes by which you can work with files. Three primary modes are read, write, or append. Now, when you open a file for append mode as out file, now we can try writing something out here. Maybe I can just type out file dot write. Sorry, off. This is a test line written using append mode. Add a new line, being sure the new lines there. Or you can also use print, no problem. Print also will work. You can say this is another line appended using print. But the only thing you do is when you use print, use file is equal to out file as the keyword argument. That is important. Just save it. No need to save it. You just have to run it here, right? Run this cell. Now you go back and check this file out. You can see that these two lines that I added is appended at the end. Now the existing data is lost. Maybe you can try running the same cell a couple of times. It'll keep appending it. 1, 2, 3. 3 times I executed the cell. You'll see these two strings repeated thrice, as you can see here. And this is what happens when you open the file in append mode. Mostly when you're dealing with logs. If you're writing the logs, you'll normally append to them, right? And that's what it's meant for. But sometimes people ask me, can I not open the file in a mode where I can read and write simultaneously? Well, this is what you should know. You can open a file for reading, and then you can also write to it. How do you do that? Well, this can be a little tricky, and I generally not recommend it. Generally never recommend it. If you have a use case scenario where you want to do read-write operations on a file, seriously, consider using a database. That's the right thing to do. Files are best opened, read through completely, or opened and written into them. Files work best when you open only for reading or only for writing on your own. This has got to do with many reasons. One, most of your underlying operating systems manage files with some kind of buffering. So when you open a file and say, maybe a file is big, maybe you have a 1 gigabyte file. You ask the operating system to open it, a file descriptor is allocated, and then you ask the OS to read 4 kilobyte from it. The OS might actually end up reading much more than that. These are called as read ahead optimizations, read ahead algorithms. So it's like a very smart worker. You ask him to do one work, he's going to prepare much work beforehand, assuming that you'll ask him for another work too. He's doing more than what is asked for. And this is exactly how operating systems, most OSs do, right? They do a lot of read aheads. That means when I say read the first 4 kilobyte, it'll read the rest of the data and also keep it ready. And now when you try and tell the operating system, no, I don't want the rest of it, seek to somewhere else and I want to write there, it'll lead to problems with caching. I mean, the buffering, right? The whole aspect of buffering, the benefit of it is lost. So there'll be a lot of latencies involved, more disk IO involved. And when you open a file in read write mode, you need to mostly disable buffering or manage them on your own. And you need to make sure where the cursors are and all that. So you might ask me, how do text editors do? So if you look at a text editor, you open a file, the file is read into an editor. I'm editing things and then I save it. Text editors follow the pattern like this. The moment you open a file in a text editor, any kind of editor, even this tool is an editor ultimately, right? When you open this file, at this moment, the file is not left open. The file is not left open. The moment you go to the file menu and open and say, open the so-and-so file, what it basically does is, it opens a file, reads as much as it can from the file, closes the file, and whatever data is read into memory, that is what you're seeing here. You're seeing the data that's brought into memory. And the file is closed in the backend. The file is not left open. Maybe some editors create some swap files and cache files and all that. That's the editor's implementation. Primary thing, that's what they do. The moment they can make any changes here, it's all happening in RAM. And then when you try to save it, the existing file is fully overwritten with whatever is there in memory. This is what most basic text editors do. There are advanced algorithms. Some text editors do that. So if you're using some editor to open a file that runs to gigabytes, maybe 10 GB in size, they will use some interesting algorithms. They'll do some seek and tell operation. But still, you open the file, read only as much as required to be brought into RAM. If you start scrolling to the file and when you hit that floor window, then it tries to reopen the file, seek to that file, to that position, get the next chunk of it into memory, close the file off. So you're working at a window of data that's being read, brought in. The moment you try to write to it, it'll take care of opening the file in read write mode that time, R+ mode, seek to a location, overwrite that chunk alone, and close it. That's what they do, right? Only some sophisticated text editors that deal with extremely large files, if they let you open very large files efficiently, they do that. Most normal text editors don't. I don't think VS Code does it. I try opening some file which is like say about 10 MB sometime. The later literally crashed. So it's trying to read the entire 10 MB and it was collapsing anyways. So it depends on the editors. The chances are we programmers or we users deal with a file which are not that big, right? Unless they are specialized use cases. When you're dealing with voluminous amount of data, which is more structured, that's where you want to go to a particular column, particular row, make some changes and all that. You use some kind of structured data formats, and that's where database drivers and databases come to play. So files are not structured. The structure is based on human perception, based on what I think is structured. For me, the source code. From the computer standpoint, it's all stored as raw data. But in database systems, the software, the database management driver or the server will try to organize data in some kind of structured format on our behalf by using a notion called rows and columns if there are relational databases, or they use this document style database where there's some kind of topology that they create. It varies. And that's what databases are. So you're dealing with a structured data where you want to go to a node and change something, go to another node, change something else, read this node and so on. Then consider using databases than performing file IO. That's what I should know. But having told you all that, ultimately the database systems do file IO. They open file in read write mode. So I'll tell you how it is done. For this, okay, I'll show it in this cell. I'll show it here. For this, I'm not going to use a with clause. Rather, I will open the file manually so I can show step by step what's going on, right? And then I will close it. So f is equal to open up testfile.txt this time, but open the file in R+. When you open with R+, the file is open for reading, so no data is lost, but you can go back and write to it. Now, when I want to read this file, Okay, I open this file, read this file. I can just say f dot read line. I want to read just one line. You read the first line. Now I want to go back to that line. I want to go back to that line. I want to overwrite it. I want to change this list to from 10, 20, 30, 40. I want to change something else. Now, if you want to do that, there are two methods. One of them is tell, f.tell. Tell will return the current cursor. See, right now I read one line. That one line corresponds to 17th character. 17 character, sorry. 1, 2, 3, 4, 5, 6. It's painful to do this. I'll just do one thing. I'll just copy this entire string, find out the length of it. You can see it'll be almost 17. So 17 characters are being read until I encounter a new line, because read line will read up to a new line. That's what it does, right? When you say read lines, it'll read everything into a list. Right now is at that position, which is the second line. Now, let us say I want to replace some entries in the second line. What do I want to change? What is there in the second line? I don't know that. So let me do a cat test file.txt. Oh, there's something called 100. Let me do something else. Let's say I want to change that value from 100 to, let's say, 400. So what I'll do now, I can actually type f dot write of 400. I'll say 456. So closely note, I am replacing 3 characters. There were 3 characters. 1, 0, 0. I'm changing it with 456. Something like this would work. If you try to add more number of characters, it'll spill over, overwriting the new line character and overwriting the next line content. There's no way to insert word into it. Remember, you cannot insert or delete a line when you open in rewrite mode. You can only go in that, what we call as overstrike mode. In text editors, you do that, right? Overstrike. That means writes on the existing data, overwrites the existing data. So it cannot let you grow the file size, reduce the file size and all that. Yeah, you can reduce the file size, but you cannot grow it. Once you've made this write operation, the file cursor, right now let's look at the file cursor. It's at, 438. It went to the end. Actually, shouldn't have. Maybe write does something interesting. Okay. These are all high-level APIs, high-level wrappers on top of system calls. So I think after write, it automatically went to the last line, I guess. Now let's, if you want to seek back to the beginning, if you want to seek back to the beginning of the file, I can do that by using f.seek of 0. Seek can take an optional parameter to say seek related to what location. If you don't specify that, seek to the beginning, right? Related to the beginning portion. It's called seek begin, seek cur, and seek end. You can say from the end, go 10 characters before. Or you can say from the current location, go 10 characters before or 10 characters forward. You can give a positive or negative number to seek the file cursor. So if you have a file which is like a stream of bytes, right now, when you open a file, your file pointer, the file cursor, or file seek pointer rather, is at 0th position. That's in the beginning of the file. As you start reading the file, like say you read one line, the cursor moves forward to that many characters. Read another line, file cursor moves that many characters. By using seek and tell, you can reposition them or find out where they are. Tell will tell you where they are. Seek can be used to reposition them. So right now the tell says it is at 438th character. Now I want to go to the beginning. So I say f.seek of 0. Now you do f.tell. It will report the current location. You can go back and try reading it. f.read line. See, it's rereading the first line. Sometimes you want to read a file through some first few lines, go back again, read first few lines, go back again, read it. You want to do repetitive reading of a file, then you can use this technique. You can read a couple of lines, f.seek of 0, read a couple of lines, f.seek of 0. You can keep repeatedly reading the same content. Well, this is useful in scenarios where the file is being dynamically modified by some other process or some other program, and in one program you want to see those updates as and when they arrive. Not suitable for files on disk, suitable for something called as pseudo files, like proc file systems files on platforms like Linux. That's where it's useful. Okay, otherwise you don't normally use it. Now, once I do a read line, it read this. I'll read another line. Now, the second line, you can see, oh, I did write. I did write this. Oh, looks like it went to the end, is it? Yeah, it went to the end. So you can see that. If I do a read line, 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 read line. Ah, it went to the end. This is the drawback. When it's R plus mode, though I did a f dot seek and try to go to the beginning, I had to go to that location. Okay. I should explicitly call seek, I guess. Let me do that. So seek to 17th position and do a write. Let's see. F dot seek of 17. Now let me do a f dot write of 456. And now if you do a f dot tell, it's in 20th position. So if you want to write to a particular position, you have to first seek to that position and write it. Just do it. I did a read line, and then I did a write. If I attempt to write after doing a read line, right, it'll go to the end of file and write to it. That's why the file cursor when I did file.tell, it went to 438 location somewhere, right? But this time I did explicit seek to a location, wrote it. Now again, I'll go back, seek back to the beginning and see whether it's overwritten 100. F.seek of 0, and now try reading it. F.read line, F.read line. Now it's overwritten. Now you should be very careful. If you close the file now, I think at that whatever the seek pointer is, whatever f.tell reports, everything after that will be truncated. It'll not store it. So if you want to store the existing data, you have to go to the end of file. You have to go to the end of file, and then you should actually perform a close operation. And also, any write operation you perform to a file, whether you open in write mode or whether you open in read write mode like I did here, or even append mode, all write operations are buffered, which means if you look at the file content, I stored as a 456 there, but let's see if it is there on disk. Do a cat testfile.txt. Oh, it's written. Fantastic, it's written. It's flushed out. Sometimes it may not flush. The flushing might take more time. So it depends. So in this case, the data got flushed out. You can see 456 right here. But in many times, I've seen that when you perform any write operations, until you close the file or until you explicitly call the flush method, it may not be flushed out on disk. Here, I think the flush happened simply because I invoked read line. So when you do a write and followed by read, whatever data that's buffered and not written on disk would be flushed onto disk, and therefore read will be in sync with what you write. All these are algorithms and policies, I would say, very similar to these multi-version concurrency control, MVCC models we call them. Concurrency read-write operations, right? How do you model on them? Let's not worry about that. It's a database terminology again. So I'm keeping it simple. So it's mostly like read committed is what you see. That's the term that's used. That means when you write and try to do a read, when you open in read-write mode, what you write is first committed on disk, and then that committed data is what is read. That's what is the strategy being followed by default in Python. Remember, these are all Python specific nuances a bit. If you're writing the same code in other languages, they might work a little differently. I think every read line will take care of synchronizing if the file is open in write mode, read-write mode, right? Before you perform a read. So at f.tell, I can always go to the end of file now. I can if you want to seek to the end of file, I think it's easy to do a f.seek of maybe 0, seek underscore end. Oh, I should use seek underscore end doesn't work. Okay, I think this constant is not defined anymore. I had to use io.seek underscore end, I guess. So I had to use numbers. If you look at f.seek, it's a number, right? The second argument is number. The advance is a number. So if you, that can be, I think it's 0, 1, and 2, I guess. So 0 is like the beginning, 1 is current, and 2 is end. So we'll just do that. Yeah, see, it's went to 438 location, and now you can close this file. I hit the wrong key. You can use f.close. It is not synchronized on disk, so you can just do a cat testfile.txt. This one is able to change the value 100 that was there in place to 456. You can experiment and try out giving a larger string, smaller string, and see what really happens. I want you to try it out, right? So you'll know exactly what R plus means. If you open a file with W plus, the existing data is lost. The moment you start with W, that's the W key, W as a mode, write mode, that is, existing data is truncated. It's like you want to open a file in write mode and start writing to it, but you want to go back and read from the file. It's useful for that kind of use case scenarios, right? So that's what these modes are. All right. So in this video, I just told you how you can perform read and write operations both. It's a continuation from the earlier session where I only told you how to read small files and read large files, mostly text files, and for that matter. In this session, I told you how to write to a file by using write method or write lines method. And yes, there's no question of large file or small file here, because when you're writing, whatever string you want to write, you can write to that file as it is. The file size doesn't matter. The file size depends on how much data you end up writing. Okay, so if you already have a very large file and you want to add on some new lines to it, like logs and so on, obviously you want to open in append mode and then write to it, right? These are the ones you should know. To summarize, the mode argument, if you pass a R, it'll open for reading in text mode. If you use W, you'll open the file in write mode, which means if the file does not exist, a new file is created, assuming you have permissions. The file exists, the file is truncated and overwritten. That's one thing you should know about W. If you use A, the file is opened in append mode, whereby it's like write mode. It opens a file for writing, but does not truncate the file. Every writes will seek to the end of file and write to it. And then I told you about other modes which are not commonly used. I spent a lot of time telling you why you should not use it, but I told you you can in some cases. If you really want to do things on your own, you can open a file in what we call as R plus. That's read supporting write. So you open for reading, but you can always seek to that file anywhere and write to any location of that file. And that's exactly what I showed you with this small examples. Try these things out. And if you have any questions or doubts, feel free to post them in comments, or you can also connect to me directly and ask me your queries. So I'll try to help you out. And I hope you found this video useful. So if you really like what I'm doing, all these concepts, if it's adding value to your learning, please hit the like button. That way I know that I'll be more motivated to make more videos like this. And if you're not subscribed to my channel, please do subscribe to look out for more, to watch out for more videos that I might be posting in the coming days. Thank you very much. So meet you in the next video. Thank you.